let's take a look at this lottery example in Aleks. In the New York State Numbers Lottery, you pay $3 and you can bet that the sum of the numbers that come up is 13. The probability of winning is 7% or 0.07, and if you win $8, which is a profit of $5. So you paid your original 3, but then if you won 8, your net profit, your net gain is $5. If you lose, however, you just lose your original $3 bet. So the main goal in this question is to figure out the expected value of your profit, or on average, what can you expect to win or maybe lose playing this game. And so the way that we're going to do this is we're going to create a probability distribution for our discrete random variable. And in this case, our discrete random variable is the profit. So let's make a little table here where we say x is equal to the profit, and then we are also going to indicate the probabilities for the different values of the profit. Okay, and so we only have a couple of different possibilities for the value of our random variable, for the profit. And in one case, you could pay the $3 and you could win $8, and you would have a net profit of 5. So let's put 5 in here. And the probability that's associated with that is 0.07. And then the only other possibility is that you don't win. And so if you lose, then you're going to lose your original $3 bet. And the probability that's associated with that is going to be the complement to this 7%. Because if there's a 7% chance that you win, then there's going to be a 1 minus 0.07 chance that you lose. And 1 minus 0.07 is equal to 0.93. So you have a 93% chance of losing $3 and a 7% chance of winning, of getting a net profit of 5. So this is the probability distribution for our discrete random variable. And now what we're going to do is we're going to enter this table into the graphing calculator. That's probably the easiest way of going through this. All we need to do is go into stat edit, and we can enter 5 and then -3 into list 1. You can see I have 5 and -3 right here. And then in list 2, let's put the corresponding probabilities. And so our probabilities are 0.07. And let's say that you didn't want to compute 1 minus 0.07 in your head or anything like that. You could just plug that into your calculator. Say 1 minus 0.07. Oops, let me fix that. 1 minus 0.07. And the calculator will say, yep, that's 0.93. That's 93%. So now we have our profits, we have our weights, and we go to stat, calc, one variable stats. And this is where we need to acknowledge L2 as our frequency list. And so our main list of profits, of the values of our random variable, is L1, but the weights that go with those profits are the corresponding values in L2. Now, if you don't have this type of setup in your calculator, some students will press one variable stats, and what they'll get is it'll just say one variable stats. What you would need to put after one variable stats is L1, and then a comma. The comma button's right there, and then you would need to put L2 to communicate with the calculator that yes, I've got my data in L1, but I want you to weight things according to L2. But for those of us who have this set up, it's really nice and convenient. We can tell the calculator, yep, our main list is list 1, and our weights are in list 2. So we're just going to calculate, and we could see that that the average, or the expectation in terms of the profit, is a loss of $2.44. And so we can go into Aleks right here and say the expected value of the profit is, let's put in negative 244 and check that. We get the green check. And so typically, with this type of problem, if you have a positive expected profit, then that's an expected gain. And if it's a negative expected profit, then that's an expected loss for the person playing the game. And so this is an expected loss of $2.44 for the person that's playing the game. And if it's a loss for the person that's playing the game, then that actually means it's a win for the people that are organizing this lottery system. So the New York State government or whoever is doing this can expect on average that they are going to be taking from people playing the game a couple of dollars, $2.44 to be precise, on average. And so ultimately this should lead to some funding for New York State government or whatever. So hopefully this example helps. Let your instructors know if you have any questions. Thanks.